How to diagnose intermittent electrical faults. This lesson shows how to approach intermittent faults disappear during normal testing, unless the test captures the condition that causes the failure. Intermittent faults come and go because the failure depends on conditions. Heat, vibration, harness movement, load, connector stress, or time can briefly open a path, short a signal, or shift a voltage. By the time the vehicle is parked and the meter is connected, the circuit may look normal again. The diagnostic job is to recreate or capture the condition that made the ECU see the fault. Heat and vibration are not background noise. They are test conditions. A terminal may loosen as the connector vibrates. A cracked conductor may open when the harness bends. A sensor or module circuit may fail only when it is hot. If the symptom appears under load, movement, or temperature, the test has to include that same condition. Connector movement can create a fault that disappears the moment the connector sits still. Terminal tension, spread pins, corrosion, poor lock fit, or a strained harness can interrupt power, ground, reference, or signal. Watch the data or voltage while moving the connector gently and deliberately, because the movement is only useful when it is tied to a captured change. A hidden wire break can pass a static continuity test and still fail in the vehicle. At rest, the strands may touch. When the harness bends, heats, vibrates, or carries load, the path opens for a moment. That is why an intermittent open needs a loaded or active test, not just an ohms check with the circuit asleep. Scan data is helpful, but it may be too slow for a fast electrical event. A brief dropout can happen between scan tool refreshes, so the PID list may look stable while the ECU still catches a fault. Use graphing, min-max, freeze frame, a meter, or a scope when the event is faster than the data stream. Capture the failure while it is active. A meter with min-max can catch a brief voltage loss. A scope can show the exact dropout shape and timing. The important part is to monitor the suspect power, ground, reference, or signal while recreating the condition, so the fault leaves evidence instead of only a memory code. History codes, pending codes, freeze frame, and monitor status are clues about when the fault happened. Look for temperature, speed, load, time, and enable conditions. Those details help recreate the failure instead of testing a quiet circuit under the wrong conditions. The code status tells you where to look for the next proof. A wiggle test should be controlled, not random. Monitor the right PID or voltage first, then move one connector or harness section at a time. When the signal drops, stop and repeat the same movement to confirm it. The goal is not to shake the whole vehicle. The goal is to make the fault repeat in one narrowed area. Mistake to avoid: do not test only when the fault is not active. If the connector is still, the harness is cold, or the load is gone, the circuit may pass every basic check. Use the code clues to recreate the condition, monitor the right signal, capture the dropout, and prove the repeatable trigger before replacing parts. Build the test path in order. Step 1. Review conditions. Step 2. Recreate trigger. Step 3. Monitor voltage/data. Step 4. Wiggle load suspect area. Step 5. Confirm repeatability. This sequence turns the lesson into proof instead of guesswork. STEP Diagnostics. Guided Automotive Diagnostics.